Hello everyone. Let us see the second problem, that is y of t is equals to cos of 3t is equals to cos of 3t, okay, into x of t. Hello everyone. Let us see the second problem, that is y of t is equals to cos of 3t into x of t, and we have to check whether this continuous time system follows the or which holds or which do not hold the memoryless property, causality property, time variance, then stability property and linearity property. Let us check it by one. So y of t has been given, that is nothing but cos of 3t multiplied by x of t. So now consider t at t is equals to t1. If you consider t is equals to t1, then what will be the output? Output will be y of t1, y of t1, which is nothing but, put t is equals to t1 here. So cos of 3t1, cos of 3t1 into x of t1, cos of 3t1 is equals to x of t1. So you can see that the output, that is y of t1, which is t is equals to t1, depends upon the present value only. This implies that the system is memoryless system. This implies that the system is memoryless system. Also, if it depends upon the present input, then we call it that as a causal system. So basically, the system's output depends upon the present input, so it becomes a memoryless system. And if the system output depends upon the present and past input, then we are calling it as causal system. So in this case, it depends upon the present input, so we are calling that system as a causal system. Now let us consider the next property, that is a shift invariance property. So I will write it here for this particular system. The system is memoryless system and the system is causal system. The system is causal. Fine. Now next what we will take, see whether the system is time invariant or variant. Let us check whether the system is time variant or invariant. To check the shift invariance property, we have to shift the output first and then we have to calculate it. Then we have to shift the input and then we have to check the response of the system. Okay. If both the equations or both the expressions are same, then we are calling that the system is time invariant system. If both the expressions are not same, then we are calling that system as time variant system. So first we will shift the output by T0. Shift the output by T0. So we have y of t minus T0, which is equals to, wherever t is there you have to write it as t minus T0. Okay. So cos of 3, okay, cos of 3 t minus T0, okay, plus second bracket complete into x of t minus T0. Okay, this is cos of 3 t minus T0 and into x of t minus T0. If we simplify this, what you will get? Y of t minus T0 is equals to cos of 3t minus 3t0 into x of t minus T0. Now this first step is over. Okay, I will call this equation as 1 star. Okay, now shift the input. Now you have to shift the input by T0. Shift the input by T0. So what is that? That is y of t comma T0, or you can say this is equals to, we are shifting inputs, that is t minus T0. Okay, so x of t minus T0, which is nothing but your y of t minus T0. So how do we write this? X of t minus t0 is nothing but cos of 3t. Now wherever input is there, wherever x is there, you have to write x of t by x of t minus 2. How do we shift x of t? Whenever we are shifting the input by t0, okay, so wherever x of t is there, you have to write it as x of t minus t0. Okay, so remember here, so I'm writing, because of that I'm writing cos of 3t as it is, okay, and then I'm writing x of t minus t0 here. Fine. Now when you look at these two equations, that is your equation number 1 star and equation number 2 star, what you will identify that these two equations are not similar. These two equations are not similar. That means that shift at the output doesn't result in the shift at the input. This implies that this system is time variant. Time variant. Fine. Now let us go the next property. Next property is your linearity property. So your system is time variant. Time variant. Next is your linearity property. You will check whether the system is linear or not. If the system is said to be a linear if it satisfies the homogeneity and additivity property, or it satisfies the superposition principle. So now let us consider the output, that is y1 of t. Okay, so I will write it here this side. Okay, so y1 of t is equals to cos of 3t x1 of t, y2 of t is equals to cos of 3t x2 of t. So I have written it in terms of x1 and x2 to check the superposition principle. Okay, so y1 of t is equals to cos of 3t into x1 of t plus comma y2 of t is equals to cos of 3t into x2 of t. Now let us consider the third input, that is x3 of t, which is nothing but the linear combination of x1t and x2t. So a1 x1t plus a2 x2t, where a1 and a2 are your arbitrary constant. So y3 of t is equals to cos of 3t into x3 of t, which is equals to cos of 3t into what is x3 of t? x3 of t is nothing but a1 x1t plus a2 x2t. So a1 x1 of t plus a2 x2 of t, bracket complete. If we solve it, so this I will combine. So a1 cos of 3t into x1 of t plus this two I will combine, a2 cos of 3t multiplied by x2 of t. Okay. And now what is this? This cos of 3t into x1 of t. This is your y1 of t. Fine. This is your y1 of t. So that is equals to a1 y1 of t plus a2 y2 of t. a1 y1 of t, a2 y2 of t. What does define? From this expression we can say that the system satisfies both additivity property plus homogeneity property. This implies that the system is linear system. The system is linear system. The system is linear system. The next property is your stability property. So in order to check the stability property, if we provide bounded input, we must get the bounded output. Then we are calling that system as BIBO stable system. So let us consider mod of x of t is less than infinity for all the t. Mod of x of t is less than infinity for all the t. Then what is y of t? Mod of y of t. Mod of y of t is nothing but mod of cos of 3t into x of t. Mod complete this term. But now definition, or you can say a formula, mod of a into b is equals to mod a into mod a into mod b. This is not the dot product, this is the multiplication. Okay, mod a into b is less than or equals to mod a into mod b. So that's why mod of y of t is less than or equals to mod of cos of 3t into mod of x of t. Mod of x of t. Fine. But when we talked about the theta, or this term cos of 3t, okay, so cos of 3t, or you can generally we can write it as cos of theta is nothing but from -1 to or it equals to +1. The cos of theta can be, upper limit is -1, lower limit is +1. So cos of theta can goes from -1 to +1. Okay, so its range is like this. So this is your +1, this is your -1. Okay, so +1 to -1 for all the thetas. For all thetas, its value is -1 to +1. That means this particular term cos of theta, or you can say this particular term cos of 3t is bounded, or you can say it is less than infinity. It is less than infinity. Okay, so it can be a +1 or it can be a -1, and then it is multiplied by mod of x of t. So I can directly write it like this way: mod of y of t is less than or equals to mod of x of t. But what we told that let us consider, we have considered mod of x of t is infinity less than infinity. This implies mod of y of t is also less than infinity, is also less than infinity, as because as mod of x of t is less than infinity. So this implies that the system is stable. This implies that the system is stable. So y of t is equals to cos of 3t is memoryless system, it's a causal system, it's time variant system, it's linear system, it's stable system. Okay, got this? Okay.